Hello, everybody. I'm Francesc Campoy, and today I'm going to be talking about cloud endpoints. The whole point of the talk is to give you an idea of what Google Cloud Endpoints is able to do today, and to also give you a kind of let you imagine what we will be adding later on. A little bit about myself. I'm a developer advocate at Google, so my job is to advocate for developers and make them happy. And I've been working with the Go team for quite a while. And I care mostly about developer experience. That is basically my whole goal, to have developers that are happy. Means that their experience should be good. And that's why I'm so excited about Google Cloud Endpoints, because it makes developer experience for many things actually nice, which is not something that it's not always the word that you can use when you're talking about auth 2 and stuff like that. So the agenda for today is going to be, we're going to start talking first about what is actually an API, and specifically a REST API, which is part of what Cloud Endpoints can do for you. Then we're going to talk about how do you document an API. An API is many things, but it's specifically something that helps you use someone else's services. You need to tell them what they can do with your service. How do you do that? We're going to be talking about that. And then we're going to talk about cloud endpoints. We're going to talk about what you can do with it, what is the developer experience, but also about how it's actually architectured behind it, so you can understand exactly how it works and understand how you could extend it. And finally, we're going to do what the talk is about, serving your API to the world. And the world will be myself in this case, but you know, it's something. So let's start with what is an API. I'm sure that you all know what an API is. You've all used at least once an API. An API is an application programming interface. And basically, the whole point is that it allows other programs use your programs. It is not, an API is not for people to use it, it's for machines. That's pretty much it. So you could have a web page. We have a web page serving some data from a data store. And you can either use the web page. You're a human being, and you go in there and clicking buttons. But if you're a program, you don't want to go there clicking buttons, because then you need to scrape HTML. And if you've ever done that, it's not super fun, and also not always allowed. So very often, we allow this other way of using the program. Same program, just a different way of using it. Cool, so what is a REST API? I'm not going to try to remember what REST stands for, because there's no point, and it really doesn't mean that much, at least in my opinion. But REST is about these three things. We have resources, and those resources are your things, the things that you care about on your business logic. So for instance, you could think about accounts, products, I was going to say sales, but that is not the word. Whatever, you can find many different things, products, accounts, or whatever. That is the main example. Then you have the methods, which is what you can do with those. So you could create a new customer, you could delete it, you could update a customer, you could do many of the things that you can do. And the whole point is that in a REST API, those actions that you can do are actually tied to well-understood HTTP methods, right? So you have post. When you do post, normally you create a new one. When you do put, you give a key, you update it. Get is to get stuff, as it says, etc. And finally, we have the representation. And representation, in the case of REST APIs, is normally JSON. So for example, we could have here our /product that represents our resource, so all the products that we have. If we do a post and send this JSON here, what we're doing is we're creating a new resource with that post method. Pretty simple. Now, this is REST, right? This is not REST. This is gRPC. But with gRPC, you can actually do things that are very, very, very similar to REST. You can create REST, not RESTful, but REST-ish, I decided to call them, REST-ish APIs that basically allow you to do the same things with the same style, but with a different way of naming the resources. Normally, in this case, it would be product service. You can create them, call them the create method. And the representation, rather than being JSON, is protocol buffers. How many of you have used protocol buffers before? OK, so just a quick description of protocol buffers. Protocol buffers is the way we do everything at Google, basically. Many of the teams at Google, we say that what we do is we decode protocol buffers, and then we encode them again somewhere else. That's pretty much what you do most of the time. They're basically like JSON, but when you encode them, they're encoded as binary format. The encoding and decoding is way faster, and also more performant when you want to send it. At the same time, they're better for versioning. So if you have never used protocol buffers, I think it's a good thing to do. But today we're going to be talking about REST APIs, so JSON. Cool. So let's talk about the demo that we're going to be using today. We're going to be using one of the simplest demos because the whole point of the demo is not to have a very complicated demo, very complicated domain. It's to show you all the things that Cloud Endpoints can do for you without having to add basically any code. OK, so let me see. There you go. I had to restart my computer right before coming on stage, which is never a good idea. OK, so I have my container engine here. I have my container cluster. You can see my container cluster has 3 nodes running there. And if I go here and I do kube cattle or kubectl proxy, I can access this 1001 UI. And we should be able to see that I have a service right here. And that service is running my service. I'm running it on Container Engine. You could be running on App Engine. You could be running anywhere. You could be running on on-premise. That's totally fine. Cloud Endpoints works on any platform that you might want to use. So I can get that URL. Open Postman. Those are Gophers, because I write Go. Postman. There you go. So I can now send a request there. OK, so if I'm able to do copy-paste correctly, there you go, body. OK, so if I send, what is going on? Raw. There you go. OK, so I can send some JSON and say, my message is hello. And then I can send it. And I receive it back. That's it. That's everything this demo does. You send a message, and it receives this back, right? Right now, there's no Cloud Endpoints going on. It's just some containers running on Kubernetes, GKE, Google Container Engine. That's pretty much it. Now what we're going to do, of course, is to actually add Cloud Endpoints to this and see everything we can do. If I remember correctly, there you go. If you write something that doesn't correspond, it's not good JSON, it will fail. And also, if you try to send something to a URL that doesn't exist, you will get a 404. You get a 404 that is kind of an ugly one. It's just some text. So if you're serving an API, this is probably not what you want to do. But we'll see how Endpoints actually fixes that directly, whether you're having to do anything. Demoing with 2 computers at the same time is not easy. OK. OK, so we have that demo, right? And the next question is, well, I want to let people use it, to use it, right? How they can use it? What is the message they should send? What is the message they should receive? What are the paths that are accepted? What are the methods on those paths that are accepted, right? And you could do many things. You could just tell them. You can go and talk to every single one of the developers and tell them, oh, yeah, it's /echo, and it needs to be post. It needs to send JSON that has message, but message needs to be lowercase, by the way, just in case you forget. Which is, it's something that you could do, but I do not recommend that, especially if you're serving this to the world. So what do we do instead? We could show the code. And in this case, I could say, rather than telling you, I'll show you the code. So you can see this code. If you know how to write some Go code, you'll be like, OK, so there's right there if you send a post method to echo, then the echo handler function is called. So then I could follow up and try to understand what are we trying to decode, what are we trying to encode. Not perfect, but this is a little bit better than just telling people. Or you could go contract first. And by contract first, what I'm saying is rather than writing the code and telling people about it, what I'm going to do is I'm actually going to agree with people, this is my API, this is how it's going to be used. And from there, I'm going to start writing my code. And now, this has a bunch of benefits. One of the benefits it has is that it improves collaboration across teams or across projects. If I clarify my API clearly, afterwards, I could change completely the way I'm implementing behind. I could move from App Engine to Compute Engine. I could do whatever I want. If I don't break that API, I should not be impacting any of the teams that are using my service. So that is pretty important. But also, there's many other ones. And what are you looking for when you're talking about the way you document APIs, right? Like we're saying, if you specify very well what you can do with an API, then you're good. You get all these advantages. Well, the first thing you need to do is you need to be very accurate. You need to specifically say all the things that you need to do to use my service. Which means that also you need to be very expressive. Because imagine that if the language that you're trying to use to express all the things about your API doesn't allow you to say, oh, by the way, the JSON object should look like this. And finally, it needs to be readable. And when I say readable, there's actually two readables here. There's readable by humans and readable by machines, right? I want something that I, as a person, can go and read and understand correctly and have a very good idea of how to use this API. But also, as a software engineer, which kind of person maybe, what I want to do is I want to parse that description of the API so I can build stuff on top of that. So, free text, is it accurate? No. Free text feels accurate, but it's way too artsy. You can write many things in many different ways that might be ambiguous, especially if you're not a native English speaker like me. There's things that you could write that actually mean something slightly different depending on the context. So free text, not the best. But expressiveness, it's amazing. You can express everything in the world with free text, so of course. And readability, it is awesome for humans, awful for machines. We're working on that with machine learning, but I would not recommend using machine learning to parse documentation for APIs to create other tools. It's cool as a demo, but I don't think it's a very good idea. Source code on the other side is incredibly accurate. It says exactly what you want to say. There's no ambiguity. It is very expressive because you're actually writing the whole domain. Very often, the source code expresses way more than just your API. It expresses exactly all the process. But readability-wise, I'd say that even though for machines it's pretty easy to read, I mean, it depends on the programming language, but mostly programming languages are done to be parsed. Readability for human beings is not that good. Because first, you need to talk to someone that programs, and in your programming language. I program in Go. If you're a programmer that has never written in Go and only knows, I don't know, let's say Haskell. From Haskell to Go, there's a big difference. If you need to understand Go to be able to use my API, that's not a good thing. And then finally, we have design languages. And those design languages, there's many of them. But the design language is basically the idea is that you create a new language in between, right? That language, the whole idea is that it's accurate and expressive enough to be able to describe your API without ambiguity, but not completely. You're not going to be able to express the whole thing that your API might do in all the corner cases with a design language. It's not a programming language. But on the other hand, it's more readable. It is more readable in general for human beings, and it's definitely more readable for machines. That is the whole point. You're building something that is very possible. So it feels like we should go with the one that has the better trade-offs. So I go with the last one. Which one? Well, you could go with Ramel. You could go with Wisdol, I think it's pronounced. You can go with Waddle or Wadle, depending where you're from. Or you could go with Open API Initiative, also previously known as Swagger. How many of you have used Swagger? Cool. OK, so that is the one we're using. If you use Swagger, the whole point is that you're able to do many cool things. You specify mainly for components. So when you're doing a Swagger API, you have information about the API itself. It's basically documentation. You have paths. So what are the paths? What are the paths in the URL that you're serving? What are the operations in them? What are the methods for every single one of the paths? And then for input and output, you're basically defining those messages. Those messages is what we call definitions. And finally, there's security definitions. So basically, what you're going to have is, for information, in this case, we have description, a Google Cloud Endpoints API example, a title, a version, a host, which is where should I go to find this API? And then you're going to have also what are you receiving, what are you sending. So in this case, application JSON, we're receiving JSON, sending back JSON, and we're serving everything on HTTPS. All of this doesn't say anything about what you can do with the API. This is just like the documentation for humans to read, and a little bit of where to find it. I went too fast with that one. Then we have the paths. And in paths, for instance, in this case, you could say, well, if you go to /echo and you send a request, which is a post method, then you have this operation. Okay? That operation, what you're doing is saying, well, there's the description, there's the operation ID, and we're going to see what this is useful for. Operation ID is not compulsory, but it's very useful when you're generating code. And you, again, say what is producing, application JSON, and then you have responses and parameters. And this is very interesting, because basically what you're saying is, what do I get from the request? So what are the parameters that I'm receiving? And what do I send back? In our case, the responses, we're going to say, well, there's two cases. One is 200, also known as the status code OK, and in which case, we're sending the echo back. Our server, what it says, it just sends the message back. So that's what it does. And it sends something with schema echo message. And that is actually reference to a definition that we're going to see in a minute. So basically, you're saying, what are you going to send? But in other cases, default, we're going to be sending an error message. And the error message is also well-defined. So we're saying it's an error message, which is also in definitions. What do we receive? Well, that you're going to have in parameters. And we're going to say that we're receiving a message. So the schema is, again, the echo message. But what is interesting is we're actually saying this will be in the body, right? You could have many different places. You could have this as a parameter in the URL. You could have it as part of the path. There's many places where that information could be. And Swagger, or Open API specification, allows you to specify exactly where this is coming from. What does the definition look like? Well, error message, we're saying, for instance, is a type object, so it has a bunch of fields. And the fields are both required, message and code. And messages of type string, code is an integer. And you can even say it's from 100 to 600, because that's what HTTP codes are for. Cool, so what do I get from this? Actually, a bunch of stuff. You get a lot really cool things. So you can create documentation from this that is very readable for humans. You can create code. And you can even create developer portals, which is very useful. If you've ever used any Google API, for me, one of the coolest things we have is the the API Playground, the API Explorer, where you can go search your APIs, go send the message directly without having to install anything. So you understand the API before you start writing any code. So let's demo that. OK, so what I'm going to do first is make sure that my server is running locally. Not that one, but this one here. OK, that is. I should get something complaining. There you go. OK, so my server is now running. And what I can do is I can visit editor. Wrong window. Editor, Swagger, editor. Wrong window. I have too many windows. There you go, this one. And With this one, what I'm doing is basically I just copied that Swagger definition onto this editor. This editor is something that is very simple. It's online. You don't need to install anything. Now, the cool thing about this is that we can see on the right side this documentation, where you can see if you send post to echo the description, you have all the parameters. You can understand quite easily how to use it. The more documentation you add in the specification file, you get a documentation that is easier to use for your developers. And then on top of that, you can try an operation. You can say exactly what you're going to be sending, what you're receiving. It is able to tell you, actually, the message object has the echo message object has a field, which is required message, and you didn't send it. So it's able to do validation for yourself. It's able to do this validation even in a proxy that you don't need to write yourself, which is pretty cool. So you can write, hello, Google Cloud. Next. Send it there. And we get a response with a message coming back. And we can see what it looks exactly. And if you think about this, if you're offering these API, these tools to the developers that are trying to use your API, this is way more useful than amazing documentation. In my opinion, documentation is great to read it, but when I want to use your API, I want this. I want to be able to find what operation is doing what, and what are the exact fields that I need to send, try it, and then write my code that will do the same. There's an important thing if you try to do this at home. There's the fact that there's what it's called the cross-origin HTTP request. I don't know if you heard about this, CORS, C-O-R-S. The whole point is security. If you try to do this onto a server that is not running locally, you need to take care of these things. There's documentation about that. I feel like every single person that has tried to use this tool has discovered the options method. It's a method in HTTP that nobody uses it except for this tool. So you need to support it. Cool. OK, so this brings a lot of value, right? But again, this is still not Cloud Endpoints. What is Cloud Endpoints? Well, Cloud Endpoints is something that has been built to, given just this specification, give you more value. Give you a bunch of things that you need to do. If you want to expose your API to the world, there's things like monitoring, authentication that you should be doing. But you do not need to write those. So that is exactly what Cloud Endpoints does. Let's see that. Whoops. OK. So if you've used Cloud, has anyone used Cloud Endpoints like previously, like 1 year ago? OK, so this may be familiar to you. Cloud Endpoints is a framework that runs on App Engine standard environment, either for Java or Python. And that's it. No, not anymore. That's the whole point of Cloud Endpoints, is getting that idea that people loved and make it accessible to everywhere, no matter if you're running Java, Python, or Go, or PHP, or whatever language you want. And if you're running it on App Engine, or in a container, or somewhere in a machine that is hiding in your closet. We do not care about that. You're able to run it wherever. So what it is an API gateway. And it's an API gateway that is distributed. We're going to see that later on the architecture diagrams. But the cool thing is that this is very integrated, right? So it is integrated with deployments for App Engine. If you're using App Engine flexible environment, it's a great experience. It's simply you add just one little field in your app.yaml, you redeploy, and that's it. You're done, which is amazing. But for Container Engine, which is what we're going to be doing, it's very easy. And if you want to do anything else, it is doable. Might be a little bit harder to implement, but it is definitely doable. And also integrates with Stackdriver logging and Stackdriver trace. So and whenever you receive a request, you're going to be able to see that in your logs and also in traces. So you're going to be able to track, to measure latency and things like that without having to care in your code. So the key features are authentication, so you're able to authenticate users and control who has access to what. All of this just by adding things, security definitions to your OpenAPI specification. You're going to get also logging and monitoring. And this is really fast. It's incredibly fast, and it scales really well. And we're going to see why. It's like I'm not a marketing person, so I'm going to explain why this is fast and scales very well. You can run it anywhere. You can run the endpoints thing, that API gateway. You can run it on App Engine. So if you run it on App Engine, you can run it on App Engine Flexible for whatever you want to do, or App Engine Standard with the frameworks for Java and Python. You can run it on Container Engine. You can run it on Compute Engine. Or really, you can run it anywhere where you're able to run a container. If it runs on a container, you can run it. So how does this actually work? Too much padding yesterday, my voice is destroyed. So first what you do is you deploy an API. What you do is you call with G-Cloud, you send the API specification, that openapi.yaml file that we saw before, and you send it to the Google Service Management. What you're saying here is you're declaring something new, and you're going to get an API name and a version. Then, when you run that gateway, the gateway is going to communicate with the Google Service Management, and it's going to say, hey, I want to serve this API name and this version. Give me everything I need. Basically, it's going to get all the information from the API, plus authentication, all the stuff. This is just the deployment part. That's it. So that's why you can run that container engine anywhere. As long as you can, that container for endpoints, as long as you're able to use the Google Service Management API, which is simply a REST API, you're able to do this. And then when you get a request, no matter what client is sending it, rather than going directly to your code, it goes first to that container. The container checks with the Google Service Control if this is allowed or not. If it is allowed, it sends it to your actual code. That, again, could be running anywhere. And finally, it logs everything to Stackdriver for logs and monitoring and traces. That's it. This is the whole thing. Now, the important thing is that I don't know if you're able to see it. I'm not really able to see it. But there's a little blue box surrounding both the extensible service container and my code. That box is a node. And I'm calling it node because it could be anything. It could be a pod on Kubernetes, but it could also be an instance, an actual node, a virtual machine, or it could be anything else. The whole point is that this is running together, right? And the point of running together is that since you're exactly in the same machine, there's no network hops to be added. So this is very fast. So it is faster, and it scales with your app. What do I mean by it scales with your app? You have one gateway per container, or per unit of whatever you're trying to use as your backend. So you could put a load balancer there. And the request will go to the load balancer, and rather than going directly from the load balancer to your code, you're sending from the load balancer to the extensible service proxy, and that one will call the functions, the calls as we said before, and then send it to your backend. And this, you can add more and more. As you can see here, the extensible service proxy, ESP, is never the bottleneck, because it keeps on scaling with you. So you can imagine how this scales very well with Kubernetes. You just create a pod with two containers. One container is your backend code. The other container is the ESP as a sidecar, we call it. So let's do that. OK, so the important thing here is my Go program will not change at all. It's going to be exactly the same code, so I don't need to change it. But I'm going to kill the server. What I'm going to do is I'm going to go to my 01. I have my openapi.yaml. OpenAPI.yaml is exactly what I showed you before. expressing all the methods for every path, the definitions, etc. So you have the echo message, the error message, and that's it. There's no security here yet. So what I'm going to do is gcloud service management deploy openapi.yaml. Wow, my computer is not the fastest. There you go. So now what we're doing here is, as I said before, we're actually talking to gcloud is talking. Oh, permission denied. Oh, I'm in the wrong account. Gcloud auth list. Endpoint prog. That one. Gcloud config set project. Let me make sure that is the good one. Cloud next endpoints. Cloud next endpoints. OK. Let's try it again. OK, cool. So now what this is doing is sending that openapi.yaml to Google Service Manager. And it's going to deploy that information. It's going to analyze it. So you're going to see a warning there saying, hey, the post in echo is not protected at all. Anyone can do whatever they want with this. Are you sure? For now, yes. I am pretty sure that it is what I want to do. But the whole point is that now it's deployed. We're ready to continue. There's two pieces of information that we care about in here. We get this version here, the API version. And also we get the echo API endpoints cloud next endpoints cloud.gug. That is the endpoints, your API name, your API ID, which is unique to you. You can see it's unique because cloud.gug is not unique, but this is the project name. Cloud next endpoints is your project name, so no one else other than you has access to this. Cool. So now what I'm going to do is going to edit my container engine.yaml. So container engine.yaml, what we have is here we can see there's two containers. There's the container down there. It's the echo container, which is the important one. It's our business code. And it's simply a container in Google Container Registry that I put previously, because the Wi-Fi is not the greatest, but it's already there. And then we have the container on top, which is ESP. And on ESP, you can see that we have a couple parameters. One of the parameters is what port this is serving, 8081, which means that a load balancer will be sending traffic to that port. It has the traffic where it should be sending this back. So where is your backend, which is localhost 8080, which is where my Echo server is running. And then we have the name and the version. So I'm going to change the version. I'm going to update that. I'm going to set the new one. And now everything I need to do is redeploy my server. So to do that, simply I do kubectl apply -f container engine. So now what I did is I updated this version. So now my new servers are running here. We can go check that out. Oh, that is already running. So we can go directly to localhost 8001 UI. We should be able to see that there's a deployment. But if we go to pods, there's one single pod running with two containers. That has now those two containers that we decided. If we want to add a little bit more, we can say container engine YAML. The replica should be, let's say, 3. I reapply. And quite fast, should be able to see that now there's 3 pods. Every single one of those pods has one container running my backend, one container running the endpoint proxy. Cool. So let's try this again. Let's make sure that I'm still running on the same service. This is the external IP that I'm going to be using, which I don't think changed. Let me see. No, it did not change. OK, so now I can send the message, and it still works. It is amazing. We did not do anything. But if you do things that are not correct, you're going to see that this is actually a little bit different now. So if you send a path that is not accepted, this path, this request, never got to my backend. Instead, is the ESP container saying that that was not allowed because the method does not exist. Same here. If you send something that doesn't work, it doesn't work either. Now, another benefit that I forgot to mention before is the fact that, OK, so now you have endpoints, you have Swagger, you're able to have all this documentation, but there's actually more than that. You're now also able to go away. No, doesn't want to go away. There you go. You can generate code. And there's a bunch of options that you can generate. The cool thing about this is that, yes, I can now use your REST API. Yes, there's now some limitations that have been added. There's logging and all that stuff running. But there's also the fact that if I want to generate, let's say PHP, why not? I can come here, open my PHP code, and the library model, it created the echo message. I'm not going to show much code, just to give you an idea that this was auto-generated directly. So now you have the capacity of generating customer libraries for all the languages that Swagger supports, which is actually many of them. There's actually not that many languages that people really use in production that are not supported by Swagger by now. OK, so now if we go back to my console here, that one is. We have our endpoints. So many of them now. I remember 2 years ago, there was nothing there. And we have CloudNext endpoints, this one here. So that one was added now because I deployed this, right? So if I send requests, let's send a bunch of requests with this. Requests that work, maybe. So this is my load testing. There you go. It's like Candy Crush, but with HTTP. OK, so now you can see that I got to an amazing 0.05 requests per second, which is pretty sad. But you can see how the monitoring went up directly, right? I did not have to do anything. Now I have monitoring. I'm able to see what's going on with that measure. I'm able to start to create alerts. I'm able to say, normally I have around 1 request per second. If I don't have any requests per second for a little bit, something's wrong. You're able to alert your developers about these kind of things, which is pretty amazing, because it's simply stack driver. You can also go here and see a little bit more information about the logs. What are the requests you actually received? And you can see there's all this information. There's not much, but you can actually see that for every single log, what is this status code that it was returned, and who rejected it, basically. OK, so as we said before, this is amazing. Now everyone can use my service. But that's maybe not what I want to do. I don't want everyone in the world to be able to use my service. For an Echo server, I'm pretty confident we're fine. But if you're doing something that involves actually requests that are expensive, for instance, you might want to secure this. So how do we add authentication? We have monitoring and tracing. How do we add authentication? Let's go back there. Let's talk about authentication now. There's 4 methods that are supported by Cloud Endpoints. There's Firebase, Auth0, there's API keys, and there's JSON Web Tokens, also known as JUT, I've heard, which is crazy. So what I'm going to be demoing today is API keys only, because I think it's pretty interesting. If you're a developer and you have an API that you're exposing, think about how hard would it be to implement this safely. To implement something that anyone in the world can say, create a new API key just for themselves, and start using it, and make sure that no one else has access to it no one else, that you're able to successfully identify who is using what. So this is actually incredibly simple on the Swagger point of view. In Swagger, everything you're going to say is you're going to create that security definition that says API key. And you say the type is API key, and it's something, it's the parameter that's going to be in the query. So basically, question mark key equals that API key. That's what you're specifying there. And then you're saying that the post method on echo is protected by API key. That's it. That's everything you need to do. So let's do that. So here, I should have my OpenAPI.yaml. Oops, there were two. OpenAPI.yaml. Here on OpenAPI.yaml, just added these lines at the end, security definition saying there's an API key that is in the query. And then I said that I'm requiring API keys for post on echo. So I'm going to do gcloud service management deploy OpenAPI.yaml. And this what it's going to do is going to redeploy it again, same thing. And now, does that mean that I'm actually squashing the previous version, and all of a sudden I just migrated everyone to the new version? No, that'd be pretty awful, because it would mean that you're not able to do any test, basically. What is going to happen is it's going to give us a new version. And that version, no one is using it yet. We're going to need to then update our Kubernetes cluster or App Engine or whatever you're using to use that new version. And then there you can do rolling updates or whatever you normally do to make sure that your new version doesn't break prod. So we got a new version right here. So I'm going to change my container YAML, go to V. Now, I forgot this one here. Whoa, Vim is fun sometimes. Cool, that looks good. OK, so I just changed that. And then kubectl apply. Now this changed the service. Now the new ESP container is actually using the new version. So if we go back here and try to send a message, that should not work. That's it. Now we have API security, API keys that is exposed here. Method doesn't allow unregistered callers. Please use API key or the form of API consumer identity to call this API. Who wrote that? Not me. Yay. This is super simple to use, and it's now secured. My Go code has not changed yet. So how do we make this work? I want to call that API. So the way it's going to work is I need to go to here, and I'm going to create API manager. I'm going to go to credentials. I'm going to create a new API key. I'm going to copy here, go back, and say key equals that. I'm going to send it, and now it works. And this is pretty cool, because it means that anyone can go and create a new API key and start using it and be identified. So make sure I'm not following the script at all anymore for the demos. I want to make sure I don't forget anything that I want to tell you. Cool. So yeah, this now works. Our next step is, OK, so API keys are cool, but are they actually safe? There's a very good document written on this on the documentation that we published not that long ago. You can go read it. But the interesting thing about it is that they're not, basically. An API key has a big problem, which is you're sending it with every single request. So you're sending an API key over HTTP in a URL. That's going to get logged somewhere. Everyone's going to find it. You're out of luck. You could also put it in your HTML if you want to, and that way everyone can have it too. So it is not super safe, but when you're doing authentication across different projects, like a client that has an API key, this is super simple and very simple to use. You don't need to go overkill with OAuth 2 if you actually trust what you're doing. If you have a binary running somewhere, it can use an API key quite safely. But for other cases, what do we do? Well, so as we said, there's the API key that you can use with the API producer being my Echo server. But also, if you have a user that wants to use this, very often what you're going to have is the end user is going to use some kind of authentication, and it's going to obtain an authentication token. And they're going to send that authentication token to my backend. The ESP, the endpoints, I never remember what it stands for. S, I think it's extensible, which doesn't make any sense. The endpoints extensible proxy will take care of that authentication for you too, to verify that it's actually sending some authentication. So for that, we can use Firebase or Auth0. Also, you can use JSON Web Tokens. JSON Web Tokens doesn't require extra steps. Actually, your backend can generate it. Firebase and Auth2, I think they're very nice because what they allow you to do is to have third-party authentication, which means that you don't need to care about what authentication you allow. It's very easy to say, I want people to authenticate with Google, but also with Facebook and Twitter and Yahoo and every other ones. Your code does not really change with this. What you're doing is you're changing the code on the client to obtain that token. That token will be from a different origin, but your code in the backend will be pretty much the same, which is pretty nice. So how do you do it? In Firebase, just create a Firebase security definition. That's it. With Auth0, same thing. You just create an Auth0 security definition. And then you redeploy. And if you want to know more about authentication, which is actually a very interesting topic, specifically how to authenticate different services, like service to service, there's a session tomorrow from 2:40. That's what I think, but they may be changed. I've heard that schedules are switching a little bit, so pay attention to that. Maybe a little bit later, maybe. And we're going to have two of the people from the endpoints team talking about what are the best practices to do authentication across services. So if you're interested in that, go check it out. Service-to-service authentication in Cloud Endpoints. OK. Last part. We said that we're going to share the API to the world. We have not shared it yet. The only person that is allowed to use it is anyone that has access to my project, my Cloud Endpoints Next project, that project ID, on my personal, well, not personal account, on my Go account, which is not good enough. I want to expose that API to anyone. How do I do that? Well, there's a couple of ways of doing it. One of the ways, I'll get to the demonstration in a minute. I thought I had a slide there. One of the ways is by email. I can say this person with this email is allowed to use it. So now what you can do is any project where that email is authorized to use it, they're able to enable that API. So that is a way of doing it, by email. You can also do it by Google mail groups. So Google groups. You can create a Google group and say any address that is in that Google group, any project that is part of that address, that is part of the Google group, will have access to this API. So you can start doing this quite simply, sharing with only the people that you care about. Whoops. So how do we do that? So what I'm going to be doing is I'm going to have two different accounts. I have my @golang.org account, and I also have my Gmail account. And what I'm going to do is I'm going to share that API with myself, because I'm very generous. And then I'm going to enable it and call it with an API key that is generated from my personal account. OK? So first step, we're going to go here to our endpoints right there. This is the one. We're going to click on Share API. And I'm going to just, OK, I'm going to remove it. I'm going to share it with myself. So I'm going to share it with campo83@gmail.com. Now you know how old I am. And, and now I have shared that API. What's next? I'm going to log in with my personal account, which, if I'm not completely mistaken, is here. OK, that is my personal account. You can see it's a completely different picture. That's the proof. And now what I can see is I can go to API Manager. It's one more API. Nothing crazy here. You enable the same way you enable the compute API. You enable any other API. I'm going to click on Enable API. And then you have that private APIs right there, which I'm very thankful it's working. And here you can see Echo API endpoints. Oh, this one here, Echo API endpoints cloud next endpoints.cloud.good, which is the name of the API that we had. You click there. You're going to see the documentation a little bit. You can enable it. And when you enable it, it says, would you like to create credentials? Which you should, because otherwise you will not be able to call it. So now I can create, let's say, other API. What? OK, let me do it again. Create an API key. Gonna get that one. And now, if I'm here, let's try with some API key that is not allowed. It does not work. With API key that is allowed that I created. I copy-pasted wrongly, I think. OK. Copy. That is the same. No. I did something wrong. OK. What I'm going to do is I'm going to fake it. So I'm going to go here. I'm going to go to my credentials. Credentials, my API key. I'm going to put it there. And you're going to imagine that that is actually a different one. And that this actually worked. Boom, done, yay! OK, so the whole idea, I'm sure I missed some steps in the demo. But the whole idea is that the API key creation now is not controlled by me. It's controlled by Google. But I do decide who has access to what. And also, when those calls are done, now they're monitored. And you're actually logging who is accessing what. And if you want to remove that access, you can easily do it by revoking the I'm sharing that API with someone. So all of a sudden, you have all of this functionality. And my code is still the same, that makes me happy. So what else can you do with Cloud Endpoints? There's actually lots of really cool stuff. If you have never used gRPC, I love gRPC. I think it's way better than REST. But it's the little problem that gRPC is amazing, and it's way better than REST. But people love REST, so you need to expose REST APIs, right? There's a really cool thing called the gRPC Gateway. And gRPC Gateway is a project that it is pretty popular now. What it does is you give it a gRPC specification, and from there, it generates a REST API, which means that you can have both at the same time without writing the documentation or anything twice. This is pretty amazing, and this is actually something very similar to what we do internally at Google. If you see Google APIs very often come in two flavors, gRPC and REST. What we do is pretty much the same. We generate the gRPC, we write gRPC. The gRPC is the fast one, is the amazing one. And REST is the one that is there for convenience, and very often is fast enough. But if you're doing things like Bigtable, Spanner, things like that, the fact that you're using JSON and you're encoding the code in that JSON is expensive enough that you might consider going to gRPC directly. And then that logo, Cloud Functions, we're working on that. There's a lot of people asking for this. Cloud Functions, I think it was announced today that they're now beta. I'm almost sure, and if not, I just announced something for you. I'm almost sure it was announced. It's now beta, so you can go play with it. And Cloud Endpoints for Cloud Functions will be there at some point, so we're working on it. And I'm very excited about this, because the experience of having serverless plus not having to write any code for authentication, logging, or monitoring is going to be pretty amazing. And with that, I'm going to finish, because there's much, much more to learn. The cool thing is that we're just starting. Cloud Endpoints is a very new project. And we have basically shown what our idea is. What is the core technology of this? But we're far from done. We're going to be adding more and more features. So if you have features in mind, let us know. We're always looking for, as I said at the beginning, I'm a developer advocate. My goal is to make developers happy. So if you have an idea on how I could make you happy, let me know. Thank you.